Hey everybody, it's Mrs. Harbin. Shout out to Olivia. Suggested this song and just want you to know that predicting products is a no flex zone. Okay? So make sure after this video notes you know the reactants, you can predict products, states of matter, and you know better than to not balance the equation. Also make sure you understand the role of a catalyst in a chemical reaction. Alright, so let's get started. Make sure you read chapter 6 and 7. There's the types of reactions in those chapters, and then you'll learn some more stuff. Alright, so first we have to be able to identify what type of reaction we're looking at just by looking at the reactant. So for combination, we're looking for 2 elements, decomp, 1 reactant, single replacement, an element and a compound, double replacement, 2 compounds, and combustion is an element and a compound, but the element's oxygen, the compound has hydrogen and carbon at least. Okay, so hey, what do we have here? Well, look, element, element. So what type of reaction? Element, element, synthesis. First job is to write the correct formula. Well, this is a metal and this is a non-metal. Get a periodic table, please. Let's cancel the charges. Sodium is a +1 charge. Sulfur is a -2 charge, so we need 2 sodiums and 1 sulfur, and that's done. We predicted the product, okay? Then you would go back and balance this equation only after you correctly write the formula of the one product for synthesis. So we need a 2 there, so we have 2 sodium, done. We'll do states of matter in a little bit. Lithium and fluorine, element, element. This is I'm sorry, I said single replacement. I meant synthesis or combination. Element, element. Stop what you're doing and look at a periodic table. Metal, non-metal. What do you got to do? You got to cancel the charge. Lithium's in the +1 family, fluoride's in the -1 family. It's LIF. Why? Cancel charge. Then go back and say, oh, I need 2 fluorines. Oh, I need 2 lithium. Then you're done. So step 1, write the correct formula. Step 2, balance using coefficients. All right. Correct formula means cancel charge. All right. Hey, what do we got here? An element and another element. Whoa. This is a combination synthesis reaction. So we need to cancel charge. Barium's in the +2 family, oxygen's in the -2 family. So we put them together and we get BaO. Remember, metals first. Metals first. All right, once you cancel charge, then you have to balance using coefficients. I need 2 oxygen, 2 oxygen. Oh, now I need 2 barium. Done. All right, step 1, recognize. Step 2, cancel charge. Step 3, balance with coefficients. All right. Hey, what type of reactions are these? 1 reactant, 1 reactant, 1 reactant, 1 reactant. It's a big reactant, but it's only 1. These are definitely decomp. Okay, so decomp is a compound going to break into its elements. So then we say which elements are in here? Well, we have mercury and oxygen. But wait, if any of those elements is a diatomic, it needs a 2 next to it. So don't forget NOF, cool, breathe. All right, oh, we got to put a 2 there. Why? Because it's diatomic. When it's by itself, it's really not by itself. Then you got to balance with coefficients. I need a 2 there and a 2 there. Done. 1 reactant. It's going to break down, decompose into its elements. The elements I'm seeing are N and H. And then I look to see if any of those are here. Oh, look. N. All right. And then we got to put in coefficients. All right. We got 2. We need 2. 2 N's. 6 H's. 6 H's. Single reactant decomp. All right. Step 1, break it down into its elements. Step 2, check if any of those elements are diatomic, and they're not. Step 3, balance the equation. Let's see, I'll put a 2 there. I'll put a 3 there. 2 aluminum, 3 sulfur, 2 aluminum, 3 sulfur. Done. Okay. Finally, this big old monster thing. This is one that we're going to see in the lab. That's why I'm showing you here. This is one whole thing. When you react this, it breaks down. Instead of into its elements, it breaks down into the 2 compounds that it is. So we're going to get a magnesium sulfate and some water. Okay. So, then you say, oh, there's a 7 there, so I need a 7 there. These are all decomp because it's 1 reactant. The only thing missing here is states of matter, and I'll get to states of matter in a little bit. But anytime you see one of our diatomics, the ones I'm pointing to are gases. All right, so look, oxygen is a gas, hydrogen's a gas, nitrogen's a gas. Aluminum is not a gas, it's a metal. Metals are solid. Sulfur is not a gas. It's a non-metal, but it's solid. Okay, this is going to be a solid, and H2O is a liquid. All right, so what about mercury? Well, mercury is a metal. You think it should be a solid, but it's the only liquid metal that we know about. Okay, states of matter are going to come in handy real quick. All right, so, hey, here's some samples. Nitrogen dioxide decomposes. Nitrogen dioxide, NO2, decomposes, only one reactant. Break it down into its elements, N's and O's, nitrogens and oxygens. And don't forget our word, NOF, cool, brr, he. Oh, look, that's a diatomic and that one. Then we got to balance the equation, so I'm going to put a 2 there because I need 2 N's. I'm going to put a 2 there because I need 4 oxygen. All right. Then you go back and say gas, 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 and this is liquid and that's solid. So then this is a gas and that's a gas. All right. Calcium reacts with oxygen. Calcium reacts with oxygen. Ooh, oxygen's one of our NOF. Hey, it's 2 elements. What's the only thing they do? They combine, or synthesis. So I need to go to the periodic table and cancel charge. Ca is a +2, oxygen's a -2, so it's CaO. All right. Then I can balance it. I need a 2 here and a 2 there. Done. All right. So calcium is a metal. Metals are solids, except for mercury. Oxygen is a diatomic, and diatomics are gases, except for bromine and iodine. Ionic compounds are solids or dissolved in water, but since there's no water, I can leave it solid. Hey, one reactant decomposes. Let's break into its elements, H's and S's. H is a diatomic, okay? Gas, because hydrogen's a gas. Sulfur's a solid. Zinc and oxygen, what's the only thing they can do is they can combine. Zinc is an always +2, oxygen's a -2. ZNO, good old zinc oxide. Ionic compounds are solids, all right? Zinc's a metal, it's solid. Oxygen's a gas. What do I do with coefficients? I need a 2 there and a 2 there. All right, predicting products. If it's decomp, you get the elements. If it's combination, you get the ionic compound. Okay. Hey, what are these? Look, it's an element and a compound. Element and compound, single replacement. So then you got to check the activity series. You got to look at the one by itself. Potassium is higher up than the metal. If it's a metal, if it's trying to kick out a metal, is it higher up? Is it more active? Is potassium more active than sodium? Potassium, sodium, it is. So then you cancel charge. K is a +1, Cl is a -1. KCl is the compound. Calcium goes and kicks out sodium. Sodium gets kicked out. So then what do? You look for any of these. NOF, cool, Bri. All right, none of those, so no diatomics. We cancel charge. States of matter. Metals are solids. Metals are solids, unless it's mercury. In single replacement, all the compounds are aqueous ionic compounds. Aqueous ionic compounds. Think about the lab. SN and AlBr, 3. Single replacement. Metal, tin. There it is. Is it more active than aluminum? Nope. No reaction. That was an easy one. All right, here we go. Element, compound. Single replacement. Bromine. Where? I can't find bromine on here. You know why? Because it's a nonmetal. Here's bromine. Is it more active than iodine? Yes. So bromine's going to kick out the iodine. So we're going to get lithium with the +1, bromine with the -1. We're getting LIBr. Why LIBr? +1, -1, cancel charge. Okay. Iodine gets kicked out. So then we check. Iodine is one of our diatomics, so we need that there. Then we need coefficient of 2, a coefficient of 2, and then we do states. Iodine is the solid diatomic. All right. LIBr and LII are both aqueous because the compounds in single replacement are aqueous, and bromine is our other liquid on the periodic table. Okay, there's only 2, bromine and mercury. All right, element, compound, single replacement, non-metal. Is chlorine more active than fluorine? No reaction. Okay. All right, next, predicting products. We're going to have to understand these solubility rules. So here's how you use it. I'm looking for silver bromide. No silver's here. Bromide is here. So all bromides are soluble. That means AQ, except if they're with silver. This is with silver, so this is a solid. Okay, I know we did this in the last one, but I didn't do some of these. So Na3PO4. This is sodium compound, and it's a phosphate compound. Oh, here's sodium compounds. They're all soluble. So I know from that that's AQ. Okay, also I could look at phosphates. Phosphates are insoluble unless they're with sodium. So it's still AQ. All right, BAS, barium sulfide. So I look for bariums. Don't have any. Sulfides, look for sulfides. Sulfides. All right, and they're insoluble unless they're with the group 1 or they're with barium. This one's with barium, so it's soluble, AQ. All right, we'll keep practicing. All right, double replacement reactions. First of all, you recognize because it's two compounds. This is why double replacements work, because you'll get a precipitate or, oh, I should put or a gas, or you'll get water as one of the products. So these are the products. If any of those three things are products, it'll work. So here's some samples. Look, I have a compound and a compound. Compound NaCl +1 -1. Compound lead 4 nitrate. Lead 4 is +4, nitrate's a -1. So I got PbNO3 4. All right. Arrow, double replacement, cancel the charge. Once it's first, it's always first. Here's lead. Lead has a +4. Here's chloride. Chloride has a -1. So I have a PbCl4, cancel charge. All right. Next, I have sodium +1. Nitrate, -1. NaNO3. Now here's where you need to know the states of matter. In a double replacement, reactants are always aqueous. Reactants are aqueous, reactants are aqueous. One of the products needs to be a solid, a water, or a gas. Neither of those are gas, neither of those are water, so one of them has to be solid. So I go back to here and I look for lead stuff. I don't see any. I look for chlorides. Chlorides are soluble unless they're with lead. All right. Lead, I threw in the PB, or lead chlorides are insoluble. So and then sodium compounds are soluble. So I go back to here and I say, okay, the lead chloride is going to be the solid precipitate. That's going to be aqueous. Am I done? No, I have to balance it with coefficients. So I'm going to need 4 nitrates, 4 nitrates, 4 chlorines. Okay, I have 4 sodiums, 4 chlorines, 4 sodiums, 4 nitrates, 4 chlorines, 1 lead. Done. Copper 2 sulfate, CuSO4 +2 -2. Reacts with barium fluoride +2 -1 BaF2. All right. Cancel the charge. All right. So we're going to take and do the switcheroo. Once first, always first. So copper's going to be a fluoride. Copper's a +2. Fluoride's -1. So I need 2 of them. And then barium's going to be with sulfate. Barium's a +2. Sulfate's a -2. BaSO4. Okay. Then the reactants are always aqueous for double replacement. And then we look to see which one of these is going to be a solid. Back to barium sulfates. Sulfates are soluble unless they're with barium. So it's going to be solid. So I go back here. Whoops, come back. So this is going to be solid precipitate, and that's going to be AQ. Potassium phosphate, K3PO4, reacts with aluminum nitrate. Why am I doing that? +3 -1, +1 -3. Do the switcheroo. K goes with NO3, +1 with the -1. Aluminum goes with phosphate, +3 -3. All right, then I check. Well, I know that these are aqueous because the reactants are always aqueous in double replacement. And I go back to my solubility rules. Here's KNO3. Potassium compounds are always soluble, so it's AQ. And then aluminum compounds, it doesn't say. Phosphates. Phosphates are insoluble. So I know that anything with a phosphate in it, unless it's got sodium, potassium, or ammonium, should be solid. Okay, back here. This is going to be my solid. This is going to be my AQ. And don't forget your coefficients. There's 3 Ks, 3 NO3s, 3 NO3s, 3 Ks, 1 Al. Done. All right. So, hey, what kind of reaction is this? Methane burn. So we have a hydrocarbon. Methane. Hydrocarbon. I'm going to tell you it's a gas. I'll tell you those ones. It burns. What makes it burn? Oxygen gas. O2 gas. What are the products always? This is easy peasy. CO2 is going to be a gas, and H2O is going to be a gas. What can I put for my products every time it's combustion? Combustion, you'll always get CO2 and H2O. Gas, 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 gas. So all I need to do is balance it. I need 2 there for 4 H's, 2, 3, 4 oxygens, 4 oxygens. Sugar burns. So C6H12O6, sugar solid. Reacts burns, we're going to say O2 gas, make it burn. This is combustion. But what do we get? H2O gas and CO2. What? Did I switch them around? I did. Look, they can go any way around the plus sign. All right, I need 6 carbons, 12 hydrogens, so that's 6 and 12 is 18 oxygen. I have 6 here, It's only 12 from here, so 12, 6 is 18, 12, 12, done. Okay, the cool thing about combustion is once you recognize, all you got to do is write down CO2 and H2O, both gases. Alright, so stating your success. States of matter. Metals are solid, except for mercury is a liquid. It's the only one that's a liquid. Metals are solid. Diatomics are gases, except bromine's a liquid and iodine's a solid. Ionic compounds are solid in decomp and combination. Ionic compounds are aqueous as reactants in double replacement and single replacement. Check your solubility rules for products in double replacement. And combustion gives gases. This is something you need to write down and get to know. Okay, so what are these? Predict products include states balanced with coefficients. Na plus Cl. Two elements, combination, cancel charge. Na is a plus 1, Cl is a minus 1, NaCl. Done with that. Coefficients. Done with that. States. Ionic compounds are solid if they're in combination. Chlorine's one of our diatomic gases. Sodium's a metal. Shoo! All right, a couple more. Let's just do this one. NaCl and H. These are both ionic compounds. They're going to be aqueous because it's going to be double replacement. So silver is going with chloride plus 1 minus 1 AgCl. Okay. Sodium's a plus 1. Nitrate's minus 1. NaNO3. Lucky us, it cancels. Coefficients 1, 1, 1, 1, done. Alright, reactants are aqueous. You go to your solubility rules, you find out that is solid and this is aqueous. Done. Okay, we'll do the rest of them in class. Be ready to do it. One more thing, a catalyst. Whoosh. So why can you get a chemical reaction to go faster? We can use a catalyst. Make sure you know this definition. A catalyst speeds up a chemical reaction without getting used up. It's not consumed. It's not a reactant. It's not a product. So you have to put it above the arrow. So what's the catalyst in this reaction? Please say sulfuric acid, H2SO4. It's above the arrow. It helps the reaction go faster without getting used up. What's the catalyst in this reaction? All right, high pressure, iron is a catalyst, and a high temperature. So you can make this reaction go faster using these three techniques. Iron is a catalyst. Okay, so catalyst is above the arrow. It's not used in a chemical reaction as a reactant or a product. It is just helping it go faster. All right, so make sure you know how to recognize. To review, recognize. Alright, I did find the clean version of this song. It took a while. Okay, alright. So, no flex zone, recognize the reaction, cancel ionic charge, activity series signal, solubility, double replacement, always the same, CO2, H2O. Know your diatomics, Nafko Briha. Peace out, read your book.